This question is about acids and bases found in the home. Part A. Ethanoic acid CH3COOH is the acid present in vinegar. A student carries out an experiment to determine the pKa value of ethanoic acid. The concentration of ethanoic acid in the vinegar is 0.870 moles per decimeter cubed. The pH of the vinegar is 2.41. Part 1. Write the expression for the acid dissociation constant Ka of ethanoic acid. The basic expression for Ka is that Ka equals H plus times A minus divided by HA. If we apply this to ethanoic acid, our expression for Ka would be H plus multiplied by CH3COO minus as our A minus, and then over ethanoic acid, or CH3COOH. To get the mark for this question, you need to have the correct expression for Ka. Part 2. Calculate the pKa value of ethanoic acid. Give your answer to 2 decimal places. First, let's highlight key pieces of information in the question. So we've got the concentration of ethanoic acid, which we can then plug into the expression for Ka. We've also got the pH of vinegar, which we can use to work out the concentration of H+, with the general equation being the concentration of H+ equals 10 to the minus pH. So in part 2, we write the concentration of H+ equals 10 to the minus 2.41, which equals 3.89 times 10 to the negative 3 moles per decimeter cubed. First, we need to make the assumption that the concentration of H+ equals the concentration of A-. And the reason for this is because all H+ ions must come from the acid. Therefore, when we plug into the equation for Ka, we have Ka equals 3.89 times 10 to the negative 3 brackets squared, because H+ equals A-, so we're multiplying the same concentration twice. In other words, we're squaring the concentration. And then we're going to divide by the concentration of ethanoic acid, which we've been given in the question, is 0.870. So that will equal a Ka value of 1.74 times 10 to the negative 5. But we're asked to work out the pKa value. So we do pKa equals negative log 10. We're using the same equation we would use for pH, but instead of H+, we're using Ka. So negative log 10 multiplied by 1.74 times 10 to the negative 5 equals our pKa value of 4.76, which we write on the answer line. Just briefly explaining where this equation for pKa comes from. When working out pH, you do negative log 10 H+, so pKa would be negative log 10 Ka. To get the 3 marks for this question, you get your first mark for working out H+ concentration, or 3.89 times 10 to the negative 3. You get your second mark for working out Ka, is 1.74 times 10 to the negative 5. And your third mark for working out the pKa value correctly and writing it to 2 decimal places, so 4.76. Part 3. Determine the percentage dissociation of ethanoic acid in the vinegar. Give your answer to 3 significant figures. To answer this question, we first need to know the equation for percentage dissociation. So the equation for percentage dissociation is the concentration of H+ divided by the concentration of HA multiplied by 100. In this question, that would be the concentration of H+, which we've worked out is 3.89 times 10 to the negative 3, divided by the concentration of HA, which is 0.870 times 100, gives us a percentage of 0.447% to 3 significant figures. So writing this on the answer line, 0.447%. To get the mark for this question, you need to write 0.447 on the answer line in order to get this mark. Part B. Many solid drain cleaners are based on sodium hydroxide, NaOH. A student dissolves 1.26 grams of a drain cleaner in water and makes up the solution to 100 centimeters cubed. The student measures the pH of this solution as 13.48. Determine the percentage by mass of NaOH in the drain cleaner. Give your answer to 3 significant figures. Firstly, let's highlight key pieces of information we need to use in this question. Firstly, the mass of drain cleaner that the student is dissolving, and the volume the solution is made up to. Then the fact that the pH of the solution is 13.48, and we're asked to give our answer to 3 significant figures. These are the key pieces of information in this question. Like in part A, we're going to be using the equation H plus equals 10 to the minus pH to work out our H plus concentration. In the setting of this question, that would be 10 to the minus 13.48, which gives us a H plus concentration of 3.31 times 10 to the negative 14 moles per decimeter cubed. But we're dealing with a strong base, sodium hydroxide, so we need to work out the concentration of OH minus ions, which will be Kw divided by the concentration of H plus ions. In this question, you get given the value of Kw in your data sheet, and that is 1 times 10 to the negative 14. And then we divide it by the concentration of H plus ions, which we've worked out is 3.31 times 10 to the negative 14, which gives us an OH minus concentration of 0.302 moles per decimeter cubed. Next, we need to focus on how we can calculate the percentage by mass of sodium hydroxide in the drain cleaner. In order to do this, we need to use 2 equation triangles, our first being NV times C to work out moles, and our second being mass is equal to moles times RFM. So firstly, working out moles, that would be concentration 0.302 times by volume, which is 100. We're given that in the question, as we're told that's the volume the student makes a solution up to. But we're told it's centimetres cubed, and we want decimeters cubed, so we need to times by 10 to the negative 3 to get 0.0302 moles. Then working out mass, that would be 0.0302 times the relative formula mass of sodium hydroxide, which is 40. So that gives us a mass of 1.21 grams. And we want the percentage by mass of sodium hydroxide in the drain cleaner. So that would be 1.21 divided by 1.26 times 100, which gives us a percentage of 95.9%. Writing this on the answer line, 95.9, and that's to 3 significant figures. To get the 4 marks for this question, you get your first mark for working out the concentration of H+, your second mark for working out the concentration of OH-, your third mark for working out the mass of NaOH in the drain cleaner, and your fourth mark for working out the percentage by mass of NaOH in the drain cleaner, so 95.9, which is the answer written to 3 significant figures. Part C. Sodium carbonate Na2CO3 is a base used in washing soda. Na2CO3 contains the carbonate ion CO3 2-, shown below. Draw the dot and cross diagram for the carbonate ion, show outer electrons only and use different symbols for electrons form C and O and any extra electrons. In this question, we're given the structure of a carbonate ion, so we can use this as a guide when drawing our dot and cross diagram. We'll have our central carbon, our single bonds between two carbon and oxygens, and then a double bond between a carbon and oxygen in the carbonate ion. Oxygen has 6 electrons on its outermost shell, so we can complete the electrons around oxygen by completing the number 6. So in the carbon double bond oxygen, it's already donated 2 to make the double bond, so we have 4 more to fill. And in the single bonds, they have 5 more to fill its outer shell, because it's only used 1 to make its single bond. But it needs 8 in its shell or outer shell. The carbon double bond oxygen has 8 already, but the carbon single bond oxygens don't. They also have a negative charge, so that's reinforcement that we've done this correctly. And we're told to use different symbols for electrons from carbon and oxygens and any extra electrons. The extra electrons are what create the negative charge, so we could use a square or a rectangle, for example. And finally, we need to put our dot and cross diagram in square brackets with a 2 minus charge to signify that it's an ion we've drawn here. To get the 2 marks for this question, you need to have the correct dot and cross diagram with the correct electrons and different symbols and the 2 minus charge.